Perfect. So what I did was, and I don't know why the stream really broke down, but what I did was creating a new console application, and you can do that by pressing Command-Shift-N when you have when you have Xcode opened, and then when you see the choose a template for your new project screen, then you can select application from the OS X section, and there you will find a command line tool. Simply give it a name, and make sure that you've chosen Swift as the programming language, and then you should see something like this. And what we want to do now first is exploring this a little, because it is kind of different to what we have seen so far, because in this template, the only thing that we have created here is a main.swift file where it says print hello world, which means that we would simply get a console output, just like in the demo earlier, where it says hello world. And this is kind of this the thing I intended, since we don't have to worry about different things like UIKit elements or creating a user interface at all. It's purely going to be about how to create classes, how to work with objects. And this makes definitely sense for now. And we're now going to create our first class. So I'm going to create that by pressing Command-N on the keyboard. And this gives me the possibility to, again, choose from a template file. And I'm going to choose Swift file here. And again, this is maybe something that is not visible in the stream, but simply select Swift file, not a Cocoa Touch class, not an Objective-C file, simply a Swift file. And I'm going to give it the name of Planet. And this is the first class that we're going to create. So I created the planet.swift file just now. And all we need to do now to create a class is writing the keyword class. And then we give it a name. And in our case, this is going to be Planet. And since there is going to get some information into that, we're using some curly braces to define an area where we can actually define all the properties and functions that we can use. And our Planet class has, just as a car has different properties, also should have two very simple properties. The first one is going to be a name, which is going to be of type string. And we can define that as a constant. And the second property that we're going to define is description. And again, this is going to be a string. And notice that we get an error here, and the error tells us that Planet has no initializer. And we're going to explore what an initializer is. So to create an initializer, we're simply writing the word init, which is the keyword for an initializer. And this is not actually something like a function without the func keyword. So we can also define a parameter list within parentheses, and we can also define a code block with curly braces. So this is the basic structure of an initializer. And now, since we have two properties here, we want to initialize both of them with an initial value, or when we construct our object of this class or instance of this class, we want to assign something to our name and to our description. So what we need to do is define the name and the description as a parameter of this initializer. And what we need to do then is accessing the class's name property. And since the name in our parameter is the same name as our property, they are really exactly written in the same way, we have to distinguish between the name in the parameter list and the name in our class. And to get access to a property within our class, we're writing the keyword name. We could also give our parameters here different names, like an N for our name and a D for description, but we will keep it that way. And then we could have left out the self.name, but we will do it that way. That makes the code more clear. So let's use self.description and assign the parameter description to it. And as soon as we did that, really, our error disappeared, since now we have initialized our properties. And this is all there is to it, to creating a class. And we're going to use that class very frequently in our little game. So we come to that later. But we also need another class, so which is going to be called planetary system. And to create that, I'm going to select my planet, selecting an element in our project here. Enables us to add the next file right below. So by selecting this one, planet.swift, I make sure that the next file I'm going to create, which is going to be a Swift file, so I'm going to press Command N on the keyboard, select Swift file, press Next again, and I'm going to give it the name planetary system, and I create that. Again, I think you couldn't see that in the stream, but simply press Command N on the keyboard and create a new Swift file. And by earlier selecting planet.swift and then pressing Command N and so on, I made sure that this new file was inserted right below planet.swift. That's just a nice to know fact. And in that planetary system file, we create another class, which has the same name, planetary system. And you might have noticed that I have begun each class name with an uppercase letter. And this is standard way of doing things. So we always, when we create a class, we give it a name with an uppercase letter at the beginning. And our planetary system also has two properties. The first property is a name again, which is a string. And the second property is going to be the planets property. And since we're going to have many planets, not just one, we have 8 in our solar system, it's not a bad idea to actually use an array, which you've learned in the last week about. And to create an array or to assign a type of an array, we simply use some brackets. And we can even specify that further. We can put in, you've already seen that we can put in strings into arrays, but now we have kind of created our own type with planet. So we can create an array of planets. And this is what we do right here. So we have now two properties, one property name and one property planets, which holds an array of planets. And now, again, we have an error because we haven't initialized anything. So what are we going to do? We are going to write an initializer with a keyword in it. And again, we have a parameter list, which is going to be name, a string, and an array of planets. And this is going to be of type array of planets. So again, some curly braces here, and then the assignment, self.name equals name, and self.planets equals planets. And by that, we have initialized everything that we need, and our error disappeared. Now let's also have a look at something that is called computed properties. And computed properties are a great way to decide things before you have to initialize them or do whatever you want. So this is going to be a variable. And as you've seen in the example earlier, we have the possibility to either randomly choose a planet or to choose one for ourselves. So in this case, we're going to write a property that is called random planet. And this is also going to be a planet. And in the last week, we have talked about optionals. And optionals either can have a value or don't. And if they don't have a value, they have a nil value. And so to create a computed property and to decide if we want to put something into it or not, we can simply put curly braces after the definition of our random planet property. And such a computed property always requires us to return something. So we are going to check if our array is empty. What we want to do, we have seen if statements already. And what we want to do in that case is return nil. So our computed property knows that if there is no element in our planets array, then we are going to have a nil value here. So our optional contains no value. And if you're wondering why aren't we writing something like if planets is empty equals true, so two equal signs mean an equal comparison, is we could write that actually, but is empty returns a Boolean value, so either true or false. So we can simply remove that. And Boolean values are actually the only thing in Swift that you can check that way without any comparison or of smaller, less than, or greater than, or equal to. So this is the first check that we're going to make. But we still have an error here because Swift knows that it is possible that planets is not empty. So we have to write an else statement right here. Excuse me. And in that case, we need to return a randomly chosen planet. So we create an index that will access our array, and we will need a random number. And that is pretty simply done in Swift. First of all, we need to make sure that our random number is an integer, since an index always needs to be an integer. Floating point number doesn't do much good for an index. And then there is a simple function which is called arg for random uniform, which expects a UN32. We simply hit return on the keyboard so that we can convert our number of planets. So we use planets.count. And actually the count function of an array gives us the number of elements that is located within an array. We then cast that to, or we convert it to a type called UN32. That's simply what this function arg for random uniform wants from us, so we convert it. And then, because an array index needs to be an integer, we again convert our UN32 to a simple integer value. Excuse me, I must somehow, my voice isn't that good today, but we're simply going to continue. So now there's still an error because we have missed some closing parentheses here. So we have 1, 2, 3 parentheses that are opening and only 2 that are closing. So let's make sure to put 1 at the end of that statement. And then it simply gives us an exclamation mark here because we haven't used that value. And I see the question again, because you asked if the init is like a constructor method in Java, and indeed it is. The only difference is that in iOS development, it was the same thing in Objective-C. Actually, we call a constructor an initializer. So it's actually the same thing right here. I hope this answers your question. And now what we want to do in with our index is actually returning a planet, a randomly chosen planet, and therefore we simply use the planets array, and to access a specific element from our planets array, we simply put in the randomly chosen index. And with that, we have a computed property that allows us to randomly choose a planet, and simply by doing this, we don't have to write any more functions or anything else. This is a very convenient way of doing things, but we will see computed properties in the future. So this is everything, actually everything we need to do in the planetary system class. And now we are going to deal with simply a small helper function, and we can create a new Swift file for that actually. So again, we'll select the last created file, create a new Swift file. I'm going to call that helper. And this helper function that we're going to write into this file is simply responsible for getting the user input. You saw earlier in the example that I'm able to put in data into the console, and this is going to be processed. And we're going to write a function now that will help us get this data from the console, get the user input. So we're writing a function with the func keyword, and we're going to call that get user input. We don't need any parameters here, so just some parentheses without anything in it. But we want to return something, which actually we want to return a string, which is going to be the user input. And to do that, we are using some foundation classes that Apple gives to us, and we will create a constant called standard input. And then we're going to use a class that is called NSFileHandle. And the interesting thing now is that we really don't need to know what ns_file_handle is or what it does, but we know that there is a method called file_handle with standard input. And this actually gives us the user input. And what it does is completely, we don't need to know anything about that. We simply can use it because it says it returns the file handle associated with the standard standard input file. That sounds kind of cryptic, but it's actually nothing else but getting the user input from the console. And then what we want to do is create a variable called input, and using an NS_string, which is also a class given to us by Apple. And we want to initialize our input object now, and we're using parentheses for that, with some data. And so I'm choosing, and again, this is something that's not transferred in the stream, I'm choosing the NS_string data with encoding. So this is going to look something like that. So if you're following along, make sure to select NS_string with data and encoding as an option with code completion. And the ns_file_handle with standard input gives us an NS_data object. And so we pass along the standard input right here. And there are different forms of encoding like ISO or UTF-8, and we're of course using UTF-8 string encoding. So let's build that. There's some kind of a problem here. Let me see. Let me just do that again. And a string data standard input. Oh, I forgot to use the available data. So this is simply the way of doing that. Actually, you also don't have to remember how we did that, since we're only going to do this once, and in your professional career as an iOS developer, you are most likely not using the console. So this is simply the way you access the console and the way of using that input. And then what we also need to do is using the input again, and this is why we have defined it as variable, because we want to remove the new line character set, so that we don't have any line breaks in our user input that we are going to process. And therefore we use the input. This is an optional, so we unwrap it using an exclamation mark and then simply access string by trimming characters in character set, and then we use the ns character set new line character set, and then we return our input as simple string. And this is how we actually can cast values in Swift. This is the actually only important thing that you can learn here from this little function, which is that we use the as keyword if we want it unwrapped. So if we don't want it to be an optional, we use as exclamation mark and then the type we want to cast it to. Since this is going to be an NS string, we don't want to work with an NS string, we simply want to work with a string, so we cast it to a string, and this is also what's expected as a return value. But with that done, we can now move on to nicer things and work with our planetary system and with our planets. So what we want to do is again create a new file later. Let's switch to the main Swift file that was already created for us, and let's remove the print hello world, since we want to write our own stuff within it. And the first thing we want to do is creating a system name for our solar system, which is going to be simply solar system. Very creative name. And then we want to create some planetary data, and we actually want to assign a name to a description. And a very good way of doing this is using a dictionary. And a dictionary actually is composed of a key and a value. So let's have a look at that. I'm creating a constant called planet data. And to create such a dictionary, we write, as we would with an array, we write some brackets. And then we define a key, like, for example, Mercury. And now the difference to a array is that we're writing a column. And now we can give it a description: a very hot planet closest to the sun, for example. And this is what defines a dictionary. We have a key, which is Mercury, followed by a column, and after that, a value. And we can later simply access our planet data by writing something like planet data and then Mercury, and this would return our description. And so dictionaries are a great way to structure data. But since now we have to write this 8 times for different planets, I've already prepared this dictionary for you. So everyone who has access to the iVersity course, that is a companion course to this NUMA session, to this NUMA class, go to the iVersity course and look at the associated planet data file that is created for today's session. This is simply a text file that contains the same constant that we're going to use right now. And if you go ahead and download that, I did the same thing, then you can simply copy its contents and paste it right here. So here we have the different planets like Mercury and Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And these are all the planets that we're going to use. And now that we have those planets, and we also have a planet class. The planet class, if we have a look at that again, has exactly 2 things, a name and a description. And what we have here in our main Swift file, in our dictionary, is also a name and a description. So to work with our planets more easily, it's a great idea to create planet objects of our planet data here in this dictionary. And there are several ways we could do that. One of you said that you've experience with Java development. I know there are also people who are experienced in JavaScript development. There is a simple way by creating a for-in loop. We could also create a for-in loop and create objects of our planets within a loop and then access the planet data dictionary. But there is also a very elegant way in Swift of doing things like that. So what we can do is we can create a new constant called planets. It's going to be an array of planet objects. And then we can use our planet data dictionary and use a function that is called map. Every dictionary can do that. And then we're going to define with some curly braces something that is called a closure in Swift. Actually, a function is also a closure in Swift. Actually, everything that is defined by curly braces is a closure. So this function map can do something for us. And this is amazing. We can define 2 parameters, name and description, within this closure, and then tell it that we want for every element, or for every element in our planet data dictionary, we want to create a planet with a name, which is going to be name, and a description, which is going to be our description. And by doing that, the map function, and now I must make sure that I have the right, there's a parentheses was missing. So by doing that, what we have here is an array of planet objects. And what I could do now is, let's simply try that out. We could create a constant with the name planet, access the planets. Let's use the first object, and then I could access the properties of this planet object, like the description. And if we run this application right now, then we should see something in a second. Of course, we can't see anything. I should also print it. So let me print that planet. And now we should see a gas giant with a noticeable red spot. So as you can see, we have just got back Jupiter, and this isn't the first element in our planet data dictionary, but it doesn't matter. that it's not sorted in any way. We're going to access that in a different way just in a second. But as you can see now, by using the map function, we have created an array of planet objects just in one line of code. And this is a pretty amazing feature of Swift. So now that we've done that, let's create a solar system. We're going to call that constant solar system. This is going to be a planetary system. We've also created a class for that. And then by adding a pair of parentheses, we are asked to give this some parameters. And these are the parameters of our initializers of Java developers of our constructor. And now we can pass along a name. And we have already created a name, which is our system name, solar system. So let's pass it along, system name. And then it requires an array of planets, and we just have to find an array of planets. So let's pass that along right here. And now that we have a solar system, we could also create our game. And for our game itself, we're going to create a new class. So let me select the helper.swift file and press Command-N on the keyboard, hit next, and then I'm going to create a new class or a new file that is going to be called Space Adventure. Let's create that. Space Adventure right here. And within this class, actually, the magic of our game is going to happen. So first of all, we need a property. Or first of all, we need a class. So let's create the Space Adventure class. Some curly braces right here. And now let's create a new property, which is going to be a planetary system. And this is going to be of type planetary system. And then again, we have our error because we haven't initialized our planetary system. So let's create an initializer. On parameter, planetary system of type planetary system. And then again, self.planetary system equals planetary system. All right, and now we come to the point of encapsulation, because some of the functions that we are going to write in this class only need to be accessed within this class. And one of them is going to be the display introduction function. So let's write the keyword private function display introduction. We don't need to return anything, and we don't have any parameters here. And let's see what this function does. We simply do some print statements here. The first one is going to be welcome to the planetary system that we are in at the moment. And we're going to use string interpolation here. So we use the planetary system. And the planetary system has a property called name. So we're simply using that. So by writing this, we would get something like welcome to the solar system in our case, because we have in the main Swift file, we have defined a system name with solar system. All right. So this is the first output. The next output is going to be print. There are so and so many planets in that system. So again, string interpolation with a backslash and a pair of parentheses. So planetary system and its planets array, and we count the number of elements in this array. So there are so and so many planets to explore. All right. So this is actually the introduction that we want to display. Now let's see if we can get another private function here, which is going to be response to prompt. And there we will have a parameter called prompt, which is a string, and we will return a string here. So the first thing we want to do here is print welcome. No, we don't want to print welcome. We want to print our prompt. So what this function does is it will print what we want it to say, and then it will await user input. And to get user input, we have already created a function which is called get user input. So we simply return get user input right here. And this is all we need to do in response to prompt. Then the next function, which is also going to be private, is the function greet adventurer. No parameters here, no return value. So let's create a constant with a name. And then we will use our response to prompt function, which is private, so we can use it within this class. And what we want to prompt is, what is your name? And then we want to use the name that the user inputted, and therefore we use print nice to meet you. Then string interpolation again, backslash parentheses. We use the name that we just got, and then my name is Eliza. I'm an old friend of Siri. All right, so this is what we did here, and there's nothing to return, so we can just continue. So let's give me some space here, and let's add another private function. So private, and the next one is going to be private function. Now we want to visit, and we want to specify a planet name here, which is going to be a string. And now we first want to print traveling to our planet name. So just that the user knows that we are now traveling with our spaceship. And then we actually need to identify our planet in our planets array. And therefore, we need a for loop. And we can now create a planet object by using a planet variable here, or a planet constant, and iterate through the planetary system and its planets. So this is what we are doing right here. And then we check if the planet name is equal to the planet and its name. And then we know that we have found the planet we're actually looking for. And then what we want to do is print, we have arrived at string interpolation planet.name. And then we want to give the user a description of that planet. So we use planet.description. So every time we write a dot, we are accessing the properties of our object planet, which is an instance of our class planet. So now the last function that we really, well, one of the last functions, there's only one missing then, and this is also the most complicated one in this session. So let's write private function determine destination. Don't need to return anything here. And first of all, we need to create a variable that will save the decision of our user. We will simply initialize that with an empty string right now. And then we're using maybe a kind of loop that is new to you. We're using a while loop. Last week, we only covered for loops. In this case, it's a good choice to use a while loop because we can listen for a change here. And what we want to do here is we want to check if the decision, not the division, decision, we want to check if the decision is either yes or no. And we want the inverse of that, so we'll put an exclamation mark before that. And I'm going to explain that in a second. So what we have here is a condition. We want to check if decision is equal to y, so yes, or those two pipes mean or. The decision is equal to n, so no. And if that is not the case, by putting an exclamation mark before a condition, we are inverting it. So this means not. So while not, it is not, the decision is not y, or the decision is not n in that case. So with that defined, we can now see what the decision of the user is really going to be. So we use the response to prompt then. So shall I randomly choose a planet to visit? And then we tell the user that he or she could enter yes or no. And then we will check if the decision is equal to yes. And what we want to do is we create an if-let statement and we choose a planet. So we simply use planetary system and a random planet. And this is our computed property that we've defined earlier in our planet class. So now what it does, we're no, in the planetary system class. So now we have our planetary system class right here, and there is this computed property, and we're calling it. And since our planet is not empty, we're now returning a randomly chosen planet from our planets array. So now that we have that in place, we can write visit and use our planet. And we're actually using an if-let statement here because, and we have to use the name here, the name property, because as you've just seen, random planet is an optional value, and the if-let checks if there is a value in it, and only if we have a value for planet, visit planet.name is actually called. And if that is not the case, then we will simply print something like, sorry, but there are no planets in this system. Okay, and now there's also another possibility. The user couldn't have entered Y, the user could have entered no. So we will check else if the decision is equal to N. And if that is the case, the planet name, let's create a new constant planet name, and we will wait for the response of the user. So, okay, name the planet you would like to visit. And then the user enters his best planet he could think of, and then we will write visit and planet name. Right. And else, this is the last condition that we have to think about, we print, sorry, I didn't get that. So Eliza is actually just as good at this as Siri. Okay, so now we have defined our determine destination function, and as you can see now, every function except for the initializer here is private, so we can't access them from outside our class. So we actually need a function that can start our game, and this is going to be a publicly available function. And we don't need to specify if a function should be public, so we simply write start right here. And what we want to do is display an introduction, greet the adventurer, and then we have to check if our planetary system and the planets is not empty. So we are using the isEmpty function that will return true if it is empty. So we will check if it's not empty by specifying this with an exclamation mark. And then what we want to do is print, let's go on an adventure, and then we will call our determine destination function. And that's all there is to it. So with these lines of code, we have now created our game. All that is left to do is actually return back to our main function, or to our main Swift file. And we have already created a solar system. Now what we need to do is create a space adventure. So let's create a constant called adventure. We have a class called Space Adventure. We want to create an object of it. And what it wants is a planetary system. And we have created a planetary system here, our solar system. And if with that initialized, with our adventure initialized, we can use the adventure and start the game. Actually, we should be able to do that. And I built the application, and it built without any errors. So I can run it now, pressing Command R on the keyboard. And here we go. We have welcome to the solar system. There are 8 planets to explore. What is your name? So again, I'm Brian. So nice to meet you, Brian. My name is Eliza. I'm an old friend of Siri. Let's go on an adventure. So shall I randomly choose a planet to visit? Okay. Let's see what happens if I type Y. Traveling to Earth. We arrived at Earth. There is something very familiar about this planet. So let's check this again with another planet like Mars, for example. And, oh, I didn't do that right. So let me just enter my name. I don't want to visit a random planet. I want to visit Mars. And we are traveling to Mars, and we arrived at Mars, known as the Red Planet. So this was a pretty simple game, and a lot of information about classes, different approaches, but you've seen how we can create classes in a very easy way by simply specifying the class keyword, the class name. You've seen how we can define properties, also how we initialize classes or objects of classes. We have created different objects of our classes, different instances. And if you're having a look at our main Swift file, the solar system, for example, the adventure, both are instances of their classes. And you could create different planetary systems and pass it along to your space adventure. You could create different kinds of space adventures. And this is the power of using object-oriented programming. It makes your code easier to maintain. It makes your code reusable. And actually, Swift programming or iOS programming is all about reuse things that were already created. And in the private session that will follow now, we're going to use what we have just learned and put that into practice in by working with iOS user elements and stuff like that. So thank you for everyone who chose the free plan and for watching this live session. We're now going to meet in the live classroom.